I think the organizers of this inaugural seminar series must be really pleased with the turnout, so it wouldn't be successful without you. So thank you on my behalf and that of the other speakers. So with that, let's get started. Whoop, we don't need that. There we go. I've spent my career here at RPI working on environmental problems, their mitigation, trying to understand how the environment works and so on. So my take on environmental stewardship is going to be more from a scientific point of view and more as a lifestyle. And I would hope, and I know, in fact, that it's true, because I have some of my undergraduates and my graduate students in this audience who have chosen environmental research, environmental advocacy as their profession and to build a career around those. And I hope there are others of you who will take on some of the challenges in this quote. Genesis 1:28 is probably one of the most quoted scripture verses that over the last 2 centuries has in fact been used by proponents of environmental protection. Has been used by those who have moved forth the Industrial Revolution at all costs in terms of water, air, soil, contamination, and disuse. As well as in modern times, this quotation has been used by proponents of that this is a message to us to protect the environment, to understand the environment and how it functions. So that's about all the religion I'm going to give you. All right, so my talk is split sort of in 2 parts. One, I want to just illustrate some calamities that we are faced with today, that your generation, speaking of the student body, and the generation of your children and grandchildren. And then I'll flip the coin and show where environmental stewardship has, in fact, made enormous progress in some of these calamities, but perhaps not in all of them. No matter what the environmental problem that you might think of, read about, they're all rooted in one primary tenet of ecology, and that is that all life forms are here for a reason. They have evolved very close functional relationships with all other organisms. And so whether you're talking about air pollution, water pollution, you are talking about issues that are going to have some negative impact. I was told this isn't going to work, so it doesn't. On the organization of all of nature into food chains, food webs, whether terrestrial, aquatic, marine. And so in these relationships, let's take the simple aquatic food chain as an example. The primary producers are photosynthetic. They take CO2, nutrients, they build biomass. That biomass provides for food to sustain a second level, a second trophic level in that functional group and habitat. The primary consumers in aquatic food chain, that's zooplankton. Secondary consumers are the invertebrates, little bigger organisms in the water. Planktivorous fish then is an additional trophic level, and so on. In each of these food chains, food webs, if you tug at one trophic level, you can drastically alter the function and the output. The output, obviously for humans, for mankind, is that we are the top predator, the top consumer of virtually any food chain that you would construct globally. And so this is very important in terms of looking at using marine food chains as a primary food source, or agricultural food chains, which are very small but easily disrupted, and so on. Okay? And Also note that with any food chain, the pyramid is always unidirectional towards less and less biomass as you move up in that food chain. And so when we deal with an ever-increasing human population that depends on the proper functioning of a food chain, as we disrupt the function and we do not maximize productivity as we move up in trophic level, then we pay double in terms of our environmental stewardship. So what I want to do is just pick a few examples and very quickly show you the pros and cons, how these have affected our environment, primarily how they've disrupted food chain function, and then we'll flip the coin and see what we've done in terms of environmental stewardship. So acid deposition, we don't talk about as much today because everyone's preoccupied with global change, invasive species, and so on. But this is still a very major problem globally. Basically, it's all based on burning fossil fuels. As you do so, sulfur nitrogen oxides are emitted into the atmosphere, as you can see on the left. Within the atmosphere, these oxides are converted to mild acids of sulfur and nitrate. So sulfuric and nitrate acid falls into the environment, into fresh waters. It will gradually titrate that water into an acidic condition that prohibits or eliminates within various trophic levels organisms that are sensitive to that decreasing acidity. In the top, I've already shown you food chain. So anyway, acid deposition is still a problem because we're emitting now things such as mercury within these gases, and mercury, we are doing something that this slide illustrates. Back in the 50s and 60s, there were tremendous use of insecticides, DDT. In the 70s, it was pesticides used in the fruit orchard industry in Florida, New York State, Washington State, and so on, malathion. Today, it's mercury. These materials, organic or toxic metals, in the water, in the soil, can be at very low concentrations. And people argue, well, you know, they're so dilute, they have no real significance in terms of harm to potentially humans or the top predators within a food chain. But because of this process of what we call biologic magnification, the producer community will absorb these into their biomass. They don't metabolize these. That's the problem. These are non-metabolized organics or toxic metals. These then continue to be concentrated up the food chain thousands, millions of times. So by the time a top predator, like a fish-eating bird, or humans fishing with fish that are highly contaminated with any of these materials that have been biomagnified, then they are of such concentrations, we don't metabolize them either, but it impairs liver function, kidney function, and so on. And so these are major considerations. Global warming, climate change. This is probably the most emotional issue in the last decade or so, because we've taken a basic scientific phenomenon and turned it into an emotional and political phenomenon. And has dangerous repercussions. But nonetheless, the evidence from the mid-50s, 60s, and on is that the accumulation of CO2 in the atmosphere, it creates this greenhouse effect that traps radiated heat from the surface of the Earth. And we see on the right, I was in Glacier Bay, Alaska a couple years ago, and in the couple hours I spent in Glacier Bay, there was repeated breaking off of the ice from the edge of that glacier. And that happens 24/7. And so the couple hours, I saw several dozen of these chunks of ice break off. You can just imagine how rapidly many of the glaciers around the ice is retreating. This map was just released a couple days ago by NOAA that shows the consequence of climate change impacts on the U.S. Okay, the color range from dark red to white represents the percent differences between the averages of values in all the various places where they have data from 1901 to 1960 versus the temperature difference average between 1991 and 2012. So the dark red, these are areas more than 15% warmer than in the early part of the 20th century, and those less than 15% cooler, the white areas. So you can see in the Northeast, well, you can see in Alaska what's happening is the glaciers are retreating, the northern Arctic is thawing. But in New England, upstate New York, what we will see with warmer temperatures, we are going to see a disruption of the forest trophic structure. We are going to see trees that are characteristic of the Carolinas, Virginia, moving northward, displacing many of the conifer trees that are part of the forest biome that we see now, and these will move further north. And so something like climate change will start interfering with the function of these things. Invasive species. Many of these you might be familiar with. We have wild feral pigs now in the Adirondacks. These were brought in as food stock, and they got loose. And immediately they turned wild and so on. So whether we're moving around things like tiger mosquito that brings in the West Nile virus, or we're talking about other forms, all of these have one thing in common. They are foreign to North American habitats, North American environments. Once here, they can grow very rapidly, and that growth will displace native species within one trophic level or another as you go up a typical food chain. So let's look at zebra mussel. This is a multi-billion-dollar cost a year to us now. And many of the extinctions we can pinpoint to one aquatic species, one invasive species or another. So the zebra mussel, introduced in the late 1980s in the Great Lakes, probably from water, the ballast water that was put in a ship, let's say, in Europe. And then when the ship got here into a harbor, all that ballast water was dumped into the harbor and refilled as the ship was reloaded and moved somewhere else. So let's look quickly at the movement of zebra mussels. And one of my former undergraduates in the audience somewhere collected a lot of data from USGS and wrote a computer program that I'm always pleased to show because it's so exciting. So I'm going to just rip through these slides real fast. From 1988, so the red dots indicate in that year new sightings, new documentation. Someone out there, a volunteer or a paid staff person, doing environmental stewardship. And then each year as we move up, 89, then those become gray, previous introductions, and then the red is the introductions documented for that year. So all invasive species move or are capable of moving this fast or faster across the landscape. These are aquatic organisms, so they follow lake systems, river systems, like the Mississippi River you can see is constantly being newly documented. Starting to move across the west coast, or across the mountains, now in 2008, 2009, along the west coast. So in just a little more than 20 years, this small mussel has moved and continues to move. There's a lot of new habitats yet. So from just a few occurrences in 1988, we've documented over 4,000 by now, okay, 2014. So invasive species is probably one of the major reasons that we are losing species. Now we're estimating over 35% of all mammals globally are threatened because of where they occupy within a given food chain. Amphibians, birds, reptiles, all seriously threatened. Okay, so that's all the negative side. So let's look at what environmental stewardship is all about. You might be paid to do it, environmental engineer, an aquatic biologist, conservationist, working for the Park Service. You might be a volunteer. You're just out there on your weekends helping someone document what is happening. So in 1990, the federal government passed the Clean Air Act amendments. Those amendments called for a reduction in sulfur dioxide emissions. Okay, that's the first step. When you burn fossil fuels, you get a lot of sulfur dioxide in the air. So the act was geared to designed to curb those emissions. So at the time, on the left map of the U.S., at the time of the introduction of the Clean Air Amendment Acts, much of the rainfall in the Northeast was highly acidic across the eastern part of the U.S. In 15-year time, with mandatory reduction of sulfur dioxide emissions, the rainfall now is all across the country moving into a more permissive in terms of acidity. So this is having a dramatic positive effect because we got out and the science convinced the politicians that they were in control, they could do something at the cost of continued environmental pollution. Closer to home, some of the research projects that we've been working on, and one of my graduate students, Jeremy, is in the audience. I know too, and Dave Winkler has done a lot of the chemistry. One of our Adirondack weather stations, if you look at sulfate on the left graph, over the same time period, you can see the drop in sulfate. Sulfur dioxide converted to sulfate ions, acidic ions in the atmosphere, falls out of the atmosphere. On the right-hand side, you can see a simultaneous decrease in sulfate ion in the surface waters of one of the lakes that we're studying in the Adirondacks. Brook Trout Lake has recovered to an extent over that 15 years that we've now been able to reintroduce brook trout fish, one of the top predators in that food chain, to a previously fishless lake that had become fishless because of acid deposition. So these are success stories, and they are success stories because we have collectively as a society decided to do something, and we were able to do it. Biological magnification. This is a wonderful story for all of you to use as sort of an iconic story. Back in the 60s, a very unassuming individual woman, Rachel Carson, she had a PhD in animal ecology, and she observed just around her neighborhood in Maine that each year she saw fewer and fewer raptor birds, falcons, eagles, hawks, and she saw fewer and fewer songbirds. And she began to look into why. And she found that the eggs of these birds were not forming properly because the birds had accumulated so much DDT that it was impairing their metabolic function as egg layers. And the birds were just being wiped out. Simultaneously, you could, when people started looking at breast milk of females, humans, their breast milk was also rising. You could detect noticeable concentrations of DDT. So this woman, very honestly, one person, she stood up and she wrote a book, Silent Spring, that book became so popular and so significant, it changed the entire mindset of a nation. And out of that came a demand of the electorate to form the Environmental Protection Agency in 1972. One individual standing up for what she believed. So I'm sure there's one individual in this audience who has the power and capability to do that. So success stories with invasive species, we now have in Congress, years and years too late, but we have now in the federal legislature, we have a bill that will curb the movement, the sale of invasive species from state to state, that will help curb the movement of these. So, you want to be an environmental activist. Where do you learn that the environment is important? Certainly if your parents, your grandparents are products of the 60s, you were raised in a good, positive, home environment in terms of taking care of the environment. Religious beliefs, tenets are very important, although it's hard to find a scripture verse in any of the major religions that say you should take care of the environment. But the message is there, you have to look for it. Education, role models. Role models, I like role models. Here are 5. These people, most of you probably don't even know. I've just talked about Rachel Carson. But read some of their writings, read the books they put out. The world would not look the same today without individuals like this. John Muir went camping repeatedly for years with Theodore Roosevelt. Theodore Roosevelt is credited with the national park system. It probably would have been much slower if it hadn't been that John Muir was on his back all the time, camping with him. So, the seminar delves into who we are as individuals, who we are as a society. And I think my message is that we share a sense of duty towards the environment, and with that, a sense of wonder at the enormous variety of life that's all interconnected and dependent on one another. Thank you.